All right, testing 1, 2, 3. Cool.
Yeah.
Hi, my name's Tyler. I'm an engineer here at Statsig, and today I'll be going through a onboarding session to Statsig geared towards engineers. So before we get too deep into any of the technical details, I figure it's worth talking some about why Statsig exists, why we think it's so useful, and how it's especially so useful for engineers. So at its core, what Statsig does is it lets you just control feature rollouts. I think especially from an engineering perspective, this is a fairly natural thing to want to do. You will often have some feature that's maybe not ready for general release yet, but you want to give to some set of people, whether that's your team or beta customers, beta people you're working with, or if you just have only prepared it for certain languages, certain countries, things like that. There's lots of reasons why you might want to be able to control who gets a feature, and you might also even want to be able to roll back a feature once you've rolled it out if you're realizing if, for instance, it's causing a bunch of crashes. You don't want to have to go make that code change, push that code, wait for it to deploy. It'd be a lot more convenient if you can just be like, cool, we turned it off. We're done with that feature for now. We can go fix it and then bring it back to people. But yeah, lets you have that level of granular control. And so I think that's probably the most natural entry point to Statsig is just pure feature flagging. But the really cool thing that we do after that is we let you sort of understand how your features are impacting your metrics. In the case of that feature that was bad and we needed to turn off, that might be that you were just looking at your existing diagnostics and you noticed hey, crashes went up, and we looked through the timelines and it roughly matches with when we released this feature, for instance, right? Very sort of guessworky, which in some cases is the signal is strong enough, but in other cases you're kind of maybe it was this feature. The really cool thing that you can do is you can actually treat those features as what we call A/B tests, what everyone calls A/B tests. You have some feature A, or some experience A and some experience B. In some cases, especially for feature gates, that might just be having the feature or not having the feature. And you're able to then split randomly the users who do and don't get this, so that the only difference between them with a large enough user base is that this group of people had this feature and this group of people didn't have this feature. So now you can go and look at things like, crash rate, things like that, and say, hey, the people who had this feature were crashing at a higher rate than the people who didn't have this feature. And now we actually have some actual causality, right? Instead of pure correlation, it's actually we've determined that this is the thing that actually caused this higher crash rate. And that's really cool and powerful. And the really cool thing about it is that you can extend that not just to crashes. You can actually go and look at all of your metrics and say hey, are we causing people to buy our product more? Are we causing people to do this, action in our product more? Maybe that's look at more things in our e-commerce website, or, send more messages in our messaging app. Are you starting more chats in our messaging app? All of these things that you really care about for your product, you actually get to see how your features are impacting them, which is really cool. And the other really important thing to note about this, especially for how you should sort of come at this process, is the upside for A/B testing is not actually that it means you now have all these good features that you wouldn't have had before, honestly. In fact, it's really a lot more of the opposite, things that weren't helpful or you might have missed that were causing slight regressions that build up over time. Getting to avoid all of those is really cool and powerful. Ronnie Kahavi was head of experimentation at Bing, and he did a study of all of the experiments they were running where, implicitly there's something you're trying to achieve with your new feature, right? You have some hypothesis that you're making something better, because otherwise why did you spend all the time to build this thing, right? That's a lot of engineering time spent on building a feature to not think it's going to be good. So they looked at those features and what they thought they would achieve, and they found that about a third of the time, success. We did exactly what we were trying to do. We increased revenue, etc. They found about a third of the time that I was okay, sort of, let's go back to the drawing board on this one. I don't think we quite hit the mark. Maybe there was some implementation mistake where it's on iOS we improved this, but on Android we didn't. So let's go back to the drawing board and figure out Is there a bug on Android, etc. And what they found was that about a third of the time it just was harmful. Like the hypothesis was wrong, right? They thought that user behavior would be influenced in a certain way, and it wasn't. It was influenced in the opposite way. So getting to sort of take back all of those changes that didn't help is really, really powerful in moving your metrics. And I think it's something that gives developers especially a ton of control and power and insight into like what they're doing. At Facebook, I think this is a huge part of the culture in why that company is so like developer driven and led, is because developers are thinking about their core metrics and like, okay, I've done these things and these have improved them, so I should do more things like them. And like letting you have that level of insight sort of all on your own is really cool and powerful. So talking through the different components that Statsig has to offer, we just talked a lot about feature gates. Let's get a little deeper into feature gates specifically. So a feature gate is just, it returns true or false, right? This person has this feature or they don't. There's not really more, there's no third option there. It's just a Boolean. But what is really cool is that a feature gate is made up of a series of rules, right? So you're saying, hey, this feature should be available to employees of my company. This feature should be available to early access users. Or maybe this feature should be available to everyone. And when you have some segment of users like that you're granting access to or not granting access to, as the case may be, they're all like essentially the same, right? Like there's no real difference between the people in this bucket because we put them all into the bucket because they share this property, and then every other property should be sort of randomly distributed across them. So what it means is that when you say, hey, I want to give this feature to 50% of employees, the 50% of employees who have this feature and the 50% of employees who don't have this feature, they should all be roughly the same, and we get to feel really confident that we can actually just do an A/B test. So out of the box, by default, we'll treat that as an A/B test and give you results on it and actually let you like break it down, which is really neat. In code, what this looks like is you're just calling statsig.checkGate and then the name of your feature gate, and it's just going to return true or false. There's no network call here for either our server or client SDK. We'll get a bit more in depth on the differences between the server and client SDKs later on, but it's really important, and especially to me as an engineer, right? I don't want this to be a heavy check. I don't want it to be really slow for me to determine if someone has this feature or not. I just want to call this thing and get the answer back, and both of our SDKs allow you to do that. Experiments are kind of the more advanced cousin of feature gates, and they let you do some things that the feature gates don't. There's a few sort of procedural things that we do about them, where we actually want you to come to the table with some formal hypothesis, like from your team of, yeah, this is why we're building this thing. It's not just, I have a feature, was it good or bad? It's really like, I have a feature that's trying to do X, and then we're going to answer the question of if it did X. You can really think back to like, high school, middle school science class, where you have your problem, and then you have a hypothesis, and then you run an experiment, and then you approve or reject your hypothesis, right? It's the scientific method, and it's applicable here too. This is what we want you to do, is come to the table with that hypothesis of this thing is going to help this metric and like solve this problem, right? The other thing, like technically, that it allows is ABN. So feature gates were just true or false. Experiments are, you can be in any of these groups. You can be in, control or variant 1 or variant 2, etc. The other thing about them is, rather than purely just saying, hey, this user's in this group, figure it out in code, we allow you to have parameters. And so parameters really help keep your code a lot cleaner, is our experience and why we advocate for them so strongly. For instance, if I was redesigning, say, a button, right? Some pretty trivial example like that, where I might be changing the text of the button and, the size of the button on some flow. One option that I could do is I could say, okay, give me which group this user's in. Are they in the new big button or with the new text, or are they in the old small button with the old text? And then in code, I could, do a bunch of, ternary operators or whatever to get those values into the right places based on that group assignment. But what parameters let you do is actually like say explicitly, yeah, for the test group, it's going to have the big size and also this text as my text. And then in code, you're just calling like get experiment dot get text, and you're just shoving the text in there directly, right? So it lets you like have a lot less forking of your code and be a lot cleaner, especially when you're going try to clean up the experiment later on. The other cool thing that layers let you do is what we call mutual exclusion. Some people might know this as a concept called like universes, things like that. But what this represents is, hey, if you're in this experiment, you shouldn't also be in this experiment. Maybe it's, we think the interaction effects are too high, where it'd just be too problematic, troublesome to be in both of those experiments at once. So this is how we navigate that, is saying like, okay, we're actually only going to keep 50% of people for this experiment. The other 50% of people are eligible for this experiment instead, and just no overlap. Whereas if you just have a bunch of experiments that aren't in layers, a user can have the new button, and they could also have the new checkout flow and all that, which we actually think generally is good. We think people are probably a bit more scared of interaction effects than they need to be, but sometimes you have very strong reasons to be like, okay, no, these need to be separated, and this lets you do that. So in code, what this looks like is you're still just calling get experiment instead of get feature with which experiment you care about in this instance. And then you're just going to call get on the config you get back, and that'll tell you, hey, for this value, it has this value. The thing we'll have you do here is we'll have you put in a default value in code. This is important because, if on a user's first time using your app or whatever, if they don't have like the internet connection to us doesn't go through for some reason, right? For some reason, we're not able to tell them, hey, you should use this value. You should have some safe default in code that it can fall back to as like the true default experience. For feature gates, that actually winds up just being false, and we just feel very comfortable saying, yeah, it's false. They don't get the feature. We just always opt to fall back to not giving the feature if there's, for some reason, we're not able to get anything through to that user. But for experiments, with it being so much more ABN and all the different parameters, we ask that you actually say, this is the default value in code. And just like feature gates, we avoid network calls when you're doing this like get experiment and get value of a parameter on it, which is also, again, handy for perf. And so once you've run one of these experiments, or once you've had some feature gate be running with some partial rollout, what you'll probably be interested in doing is saying like, hey, how did this impact people, right? Pulse is what we call our version of that, where we actually go through and say, okay, we've taken all the users who are in group A, and we've taken all the users who are in group B. We've looked at their metrics, and we've averaged it across them and done a few statistical corrections to help you get significance a little bit better, especially for like pre-experimental bias and things like that. But so we take those, and then we just say, okay, the test group performed X% better, plus minus some confidence interval than the control group did. And so we represent that as these bars. The right side of a bar represents the upper end of the confidence interval. The left side represents the lower end of the confidence interval. And what the confidence interval represents here is if I split this experiment, into 1,000 parallel universes, there's some variance there, like sort of inherently based on your users, right? And we want to know what is like statistically, what is the rough range of outcomes that like we think represents the true value X% of the time. In our case, we choose to go with the 95% confidence interval as the default. This is generally pretty industry standard, so we recommend you keep it, but you can change it to like 90% if you feel more strongly that you should use a lower confidence interval, or 99%. Or we give you some flexibility there, but we in general stick to 95. And so we bust it out by what we call your primary and secondary metrics. When you're defining your hypothesis earlier in the experiment setup, you actually said, hey, these are the metrics I think I'm going to move, or these are the metrics I don't want to move, right? So maybe If I'm adding a new feature, I don't want performance metrics to move at all, right? Like, don't regress the load time for my page, but do increase this other thing. So some of these are representing a hypothesis that this thing will move in a good way, and then some of them are representing that this thing won't move in a bad way. And then we let you dive deeper into those metrics as well. In addition to sort of looking at, here's all my primary metrics, here's all my secondary metrics. You can do things like slicing based on, country, device, basically whatever you can know about the user and tell us about the user. We'll let you sort of group by those and slice by those to let you really dig into the results and see what the true differences between your groups are. But in general, most of the time, you're actually just going to sort of hang out on this scorecard and use that as your main thing that you're using to decide should an experiment get shipped or not. And also, this is something where like data scientists and PMs might have a lot more input in terms of like what is an acceptable ship decision or not. But yeah, we color the error bars for you. This is based on whether or not that confidence interval crosses over the 0 line. If there's a decent chance that there's no change at all, we don't think you should read too much into that result. So those are gray bars. By default, green bars are things that went up and red bars are things that went down. But for an individual metric, you can invert that behavior if that makes more sense for you. So the last piece that developers are often involved with here, especially if you're a smaller shop and you're wearing a lot more hats, is piping through all of these metrics and events, right? Like, hey, it's really cool that we can split these people into these different groups and run these experiments on them, but what are we getting out of it if we can't actually have metrics to look at there? So events are sort of our building block for all of the metrics. They represent a thing that happened, right? Someone purchased a product, or someone clicked on a button, or someone went to a page, right? These aren't things that are themselves metrics, but they're the things that go into a metric. So for instance, with that, purchase a product case, what I'll actually care about is how much products did people purchase, or what was the value of all of the products people purchased, things like that, split by these two control groups and test groups and things like that. But you're caring about some number that came from a bunch of events. Events are that building block, and then metrics are what you're creating from that building block. By default, we actually create some metrics out of the box based on any events you send to us. So we say just like how many times did this thing happen, or how many unique people did this thing happen for. Those are our most basic out-of-the-box versions, but you can get into some pretty complicated ones through our creation flows. And so that's like really the core of how you can use the SDK to send stuff to us. You're just calling statsig.log event, and then whatever the name of the event is, a value for it, and then whatever metadata you want to put on the event. So that's just how you get in those building blocks to us. The other thing you can do is you may very well already have all of these analytics flowing through other platforms. Maybe you pipe a bunch of stuff to Amplitude or Segment or anything like that. You can totally just say, hey, import all of those from Amplitude or Segment, and we'll just take them in, treat them just like they came from our SDK. There's no real difference to us, just what path it took to get to us, whether it was directly logging to us or logging to someone else and then forwarding it along to us. The other cool thing you can do is what we call imported metrics. So this is the case where you're probably a bit more sophisticated and you already are calculating a lot of interesting things about your users, rather than trying to recreate all of that and be like, okay, these were the building blocks and then we did these transformations to it in us. You can actually just send them straight to us. The only requirement there is that we think about metrics as user day value pairs. So it has to be something where you can say, yeah, on October 12th, user ID XXX had a value of 12 for this metric. That's the only real requirement there, and then it's totally valid, and we'll just use that as a metric and do all of our same stuff to it. So now let's talk a little bit on the technical side around differences and why you might opt for our server SDKs versus our client SDKs. In general, which one you opt for will actually just be pretty dependent on your actual use case, which you're doing more stuff on. And they also work well in conjunction, honestly. So you may very well be using them together. The cool thing about our server SDKs is that they do evaluation locally. You remember on that earlier slide, I talked about here's a feature gate and it's made up of a bunch of rules. We'll actually send a version of those rules to your server and let your server evaluate users then and there. So you're going to pass in some user object to that get experiment or get feature gate call, and we'll evaluate it locally on your server and say, okay, for this user, this is the result they got. Why that is possible is because all of the assignments are actually based on, they're purely deterministic, based on a hash of the salts of the experiment or feature gate, as well as which user ID you're using. So those rules determine, hey, like, which of these percentages should I use? And then that percentage will have some salt on it that we will then use with that user ID and say, okay, you were in the 90% pass group or the 30%, 10% fail group. And so that means that if you have a large number of requests coming in for different users, you can just evaluate them then and there and just know what the result was for each experiment or feature gate. And then we do, of course, have to keep our things up to date. So we will pull from Statsig servers to your server those feature gate updates and send those to you by default every 10 seconds, but that's configurable. And this sort of breaks down how those different calls work and which ones go when and where. The last component there is just that when you have logged these, hey, this person checked this gate, that's when we determine them to have been, in one of the groups, right? We don't do that ahead of time. So then we log all of those exposure events back to us every 60 seconds in a batch. Client SDKs are more designed for a single user. We actually have some client SDKs that allow you to function a little bit more like those server SDKs if you need that behavior. But generally speaking, our client SDKs are, here's a single user and they're in some app or on your website. They're not changing into a bunch of different people while they're browsing your site. They're just them. So what we do for them is we actually just give them, hey, here's all of the feature gates and all of the experiments. Here's what your value will be for this session. When you called initialize, which is how you sort of start the SDK, you gave us a user object that was like, hey, this person is in the US and their user ID is XXX and their device ID is XYZ. We go through and say, okay, cool, for that user object, here's the different responses they might get. And then it's just in a local cache. So it's really quick lookups whenever you're calling any of those checks. So again, avoiding needing a network request every time. And so that's pretty much all you need to get on the ground and running using Statsig and get you pretty far. At some point, you might have concerns that keep you up at night around all of these system hardening things. Like, how can we're using Statsig really successfully, but now how do I make sure that if something goes wrong, I will keep not running into problems? And also just how can I make things even more performant, right? We made a lot of decisions in our implementation of things to help make reasonable trade-offs on performance, but at the end of the day, there's still some network call to us at some point on initialize or whatever, where we can't know as much about your user as you do upfront. You have to give us that information to begin with. So the first sort of performance optimization you can make is what we call target apps. Target apps are a way to allow you to say, hey, for these SDK keys, they're representing services that only care about these gates or these experiments, right? So if I have some sort of microservice architecture, maybe I do have a bunch of different backend type things that only care about certain gates. They don't need to know about all of these other ones. But especially for splitting out between your client and your server, right? If I'm doing some infra type tests, it probably doesn't matter what I download to that user's app, right? This is all happening on this end, so they shouldn't even care about it. So this lets you reduce the size of that payload that we're sending, as well as just like knowing, okay, that information's never even getting to the user, which is also nice from just a security perspective. And then there are other things that you can do for sort of perf and just letting you sleep well at night perspective is called bootstrapping. This is a way to say, hey, rather than having that client SDK have to hit us, you can actually say, hey, how about instead of hitting Statsig, you just hit me, your servers, right? Your backend. You're presumably you have some backend that is already doing stuff about this user. You can just have that initialize go straight to them, sort of short circuit us out of that process. We let the servers, they have the whole rule set, so they actually have enough to evaluate for a given user all of their gates and just pass that information right back to that client SDK. So that's a way to be like, hey, even if Statsig went down, our servers will keep serving brand new client SDKs. So end users won't see the impact as long as our servers keep running. And of course, just reducing the latency of that round trip. The final thing that, especially in conjunction with number 2, keeps you really secure is what we call data adapters or data stores. This is a way to say, I'm actually going to cache those values that we're polling for in something on our end, you as the customer somewhere on your end. So maybe you have some like Redis or something like that where you're just going to put those things. And then when you want to start a new server and it calls initialize, it can actually just grab those values right from there. So it initializes faster, and also even if we stopped sending stuff, you can keep initializing. As long as you have that value cached, you're able to spin up new servers. Those new servers can then serve new clients. So it really makes we haven't had an outage, but it makes the potential fear of that minimal. So it's a really cool sort of end-to-end ecosystem of letting you still leverage all of our features, but really, really getting into the weeds on mitigating any potential risk. Yeah, so that's pretty much a lot of what there is to know about Statsig from an engineering perspective, and hopefully gets you well on your way to implementing tons of experiments, shipping cool features, and most importantly, knowing that those features were helpful to your end users. So thanks.